So today we are gonna talk about events and the Saga pattern. So 2 years ago, for our biggest client in our biggest project that we are working on, we started publishing events for the first time. And frankly, at that time, I wasn't sure what we are going to achieve, how it's gonna affect our architecture, and what's good gonna come out of this. But I decided to look at this with open mind and see at it as some kind of experiment. And in worst case scenario, we can always throw out the event and forget about the experiment if we find out that it's not good, not useful, and just cluttering our code. But it turned out to be different. It turned out to be a good experiment, and we were very happy with the results. And what I'm gonna talk to you about today is the Saga pattern, and I wanted you to be aware that this is 2 years later after we started publishing the first event. So if you go to your home after the code base and start publishing events in your code base, don't expect to get that the next week, because it might take you much more time to reach that place. But not only I want to show the Saga pattern, which is not that hard, but I want to show you our road. So how did we get there? So let's start with that. So imagine that you have your Rails application which are using message-driven architecture, which is usually known by the event-driven architecture, but I prefer the message-driven one because it emphasizes that there are different kinds of messages in your system. So there are two kinds of messages: commands and events. So commands are, at the very beginning, when you start your Rails project, commands are your params. You have this simple hash, and it describes how the user would like to update something in your application. So you have params. And as your application gets more complicated, your forms get more complex, you might start to introduce form objects in your applications. But that might be not enough, because sometime later, even those forms can become so complicated that you realize that when you submit one form, what actually happens in your system is that you are issuing multiple commands, okay? So one big form can actually send to our system multiple commands to update multiple parts of our system. So in bigger applications that have already a few years on the production, this is actually quite typical. So at some point you might want to introduce the commands, which are smaller units. So here is an example of book entrance command. So let's say I decided to book this place, this one seat on a conference. And so there is booking ID, there is event ID, which describes that this is for developers conference. And there is array of seats, so I want to book these 2 seats. And that's my command. That's what I want to do as a user in our system. And when everything goes okay, when the command is accepted, validated, and processed successfully by either the aggregates or the service objects, what we do is we publish the events. So we can, for example, publish entrance booked event that I successfully booked these 2 seats. And usually the commands, they're coming from the users interacting with your system. So they are the ones telling our system what to do. But what would happen if the commands were not issued by the user, but by the system itself as a response to a series of things that happened in our system before? And this is what we are going to talk today about, the Saga pattern. So here's an example. So there are 4 events in our system: postal order to order, postal address filled out, PDF generated, and payment paid. And when all of those events happen at some time in our system for a given order, then we want to send the PDF via postal. That's the command that we want to trigger. So the story goes like that. In our system, we sell tickets for conferences and events, and you need some kind of ticket to enter the event, the conference, so that they let you in, of course. But some people, especially the elderly ones, don't have printers, and they don't use mobile phone to enter the event. They are not that kind of people. And so they are willing to pay for the additional service that we offer them, that we will print them the PDF of those tickets so that they can enter the conference and ship them via real postal mail. I know this is 21st century, but some people are actually buying this service. They want their printed tickets shipped to them via mail because they know the interface, they know how to handle the postal service at their area. So to make that happen, 4 things need to happen. So they need to add the additional optional service that they want the postal delivery. They need to fill out the address so that we know where they want the tickets to be sent. We need to generate the PDF of those tickets. And they need to pay for the order, obviously. But here's an interesting thing. We don't exactly know in which order those events are going to happen. So, for example, when the payment is paid and people are then in our current flow redirected to a page where they can fill out the shipment details, the postal address, at the same time in the background we are generating PDF. And you have autocomplete in your browser, and the PDF generation queue can be bigger or longer depending on how many people are buying at this time. So maybe you will fill out the postal address first, maybe we will generate the PDF. It depends on how fast you are and how fast our system is at that moment. So we don't know. And when we were designing this flow, we weren't even sure at which page on the payment flow we were going to put the form to ask people for their address. So initially we wanted to do it before payment so that we know their address. But we were worried that the conversion wouldn't be so good because people would check out that they want the postal shipment, and then they would see that they need to fill out the address, which is boring, and there are a lot of fields. So we were worried that they would skip this service and decide to go other way. So we decided to ask them for the postal address after they actually paid and they are already committed to going to the event. And if they don't, because they are so excited and close the browser tab, then we send them email reminders that they need to fill out the address to actually have the tickets delivered. So we have 4 events, very simple things, but we don't know the order. And that's where Sagas are great. They can handle even the order which is random at sometimes. So when those 4 things happened, we want to send the PDF via postal adapter, via postal service, so that they print the tickets and ship them. So this is where we are right now. And imagine this in your current architecture, whatever architecture you have. Like how would you solve that in the way you are currently doing things in your system? So would you use a cron job that iterates and just checks whether all those things happens, like every 5 minutes checking if it happened or not? So if you thought about it, then it means that maybe there's something better that we could do, because almost every time I think that something is implemented with a cron job, I think we can do a better job. And there's something showing us that the architecture is not that good if we need to use cron job to systematically check our system. So this is 2 years later, after our first event in production. This is something that we can enjoy right now, the Saga pattern. But the question is, how did we get there? So let's see the full road in the last 2 years. So first, you start with publishing events. And this is actually quite simple. You have some kind of service in your system, like register user service. You register a user. However you do, device, whatever. The user is registered. And then you just simply publish the event, user registered by email. And make sure to name your events in a meaningful way so that you know what actually happened in the system. Don't go the CRUD way, don't give me user created, user updated bullshit. So it's either user registered by email, maybe user joined from Facebook, maybe user was imported. These are 3 distinct events with different meanings, and we might want to handle them differently in our system. So we use this event store to publish. And what's event store? It's like a publish and subscribe architecture. So you publish the event and you have some kind of subscribers. We call them handlers. And the only difference is that we are also saving those events in database. So later we can see the things that we reacted to. So we publish the events. This is a very small, very simple event, just ID and user email. This is a bigger one, season pass connected to a conference. So you can buy a season pass and you will get access to multiple conferences organized by given organizer. And this contains much more attributes, as you can see. And this is okay. Smaller events, 2 attributes, bigger events, like 1,000 attributes, both kinds of them are okay. This is normal. So then you start introducing the subscribers, the event handlers, into your architecture. So here's an example of a very simple handler. It's simple because it only takes data from the published event, and it's sending to the Elasticsearch user ID, email, and some other attributes that we use. We use Elasticsearch full text search capabilities so that the customer service in our system, so that they can find the customers when they need help based on their email, full name, or whatever they can use to find the customer that just called them that he or she needs help. So the Elasticsearch is like our read model. It only contains some data. And we used to have those services that were taking a lot of dependencies, but at some point we realized that the dependencies passed to our service objects are not helping them decide whether user can register or not. They were merely interested in the fact that user actually registered, and they wanted to do some side effects in other parts of system. So for example, you registered in our system, and maybe you were invited by some kind of user. Maybe a different person sent you tickets because you are their friends, or maybe you were imported and we want to notify that now you are on this platform, or maybe we want to show you that there are some people that you already know that on this platform. So yeah, we have this event handlers, and that's the first step. They're very simple at the beginning, and you use them so that you don't have that many dependencies in your service objects. Instead, you have these handlers which subscribe to the events published by those services or aggregates. Later, you might want to have like a bit more complicated handlers. This is an example of one. So when the customer is imported into our service by a football club who decided to switch to our services and manage people going to their football matches in our platform. So we need to provide people with tickets, with access to our service, and send them welcome email and give them ability to choose their password. So this is using database configuration to find which email we want to actually send them. So it's a bit more complicated because it's not only using the data from the event itself, but also doing some kind of queries in database. And at some point you will realize that in some situations, one of your handlers can actually handle multiple events the same way. So here is an example from our system. We have 2 similar sounding events, ticket refunded and ticket canceled by admin. And you might think, well, they are almost identical. Well, in some subsystems, they are. For example, we have this scanner subsystem, which is responsible for letting you in or not to the event. So you come with your ticket, it's scanned, and either we let you in or not. And if your ticket was canceled by admin, for example, because you were misbehaving on the conference or something like that, or when it's simply refunded because you decided not to go or something went wrong, or one of your friends decided to pass out. So in the scanner subsystem, what we do in both situations is that we invoke the ticket revoke handler, and we invoke the revoke command. So we revoke access to the event itself. So it doesn't matter whether the ticket was canceled or refunded, you can't enter the event anymore, okay? But when the ticket is refunded, there is much more things involved, like monetary. So we need to update Salesforce, or we need to update reporting, so that the board of our startup knows how much money we actually earn. And we need to release those seats, so maybe someone else can buy them. But if the ticket is canceled by admin, we don't do those things. So this is an interesting situation when some of those handlers are skipped in one situation, but in other, the same handler is actually used to handle two events in the same way. And when you have handler which can handle multiple events, and when the handler needs some kind of state to decide what to do next, then you've got yourself a Saga pattern. So here's an example. We have checkbank setting Saga, and it's reacting to 3 events. 2 of them are very similar sounding: conference created, conference cloned. So someone created an event on our platform, like a conference, like 4Developers. And then we have the second kind of event, ticket kind created. So someone decided to start selling tickets on our platform for that particular conference. And here's what we do in those situations. When the conference is created, we just store some kind of data. So we need to save the organization ID, which in our system is a tenant ID. We need to save the organizer ID who created the conference, and we save that the command was not invoked yet in the checked attribute. And when the organizer creates the ticket for the first time, we invoke the checkbank settings command, which will notify the customer if they haven't yet provided us with the payout bank details, so that we know how to pay them out the money that they earn on the conference. So if they haven't yet provided that, it will send them an email saying that, hey, it's nice that you want to earn some money on our platform, that's what we are for, but if you actually want to get this money, fill out the details so we know which bank account we should pay out the amount to you after the conference is finished. And you might be thinking, well, why do we need the handler to react to conference created and conference cloned when we could invoke the checkbank setting command only when the ticket kind is created? And the reason for that is that when the ticket kind created event arrives, we don't know, for example, who was the organizer or what was the organization ID in which the conference was created. This is the information that we have from the previous events, conference created and conference cloned, and that's why in store event we store this information later. And when the time comes and we want to invoke checkbank settings command, we can use those data, the organization ID, the organizer ID that we have from the previous events, to invoke the command. And we also use the state to update the checked attribute so that we only invoke the command once, even when there are multiple tickets created for the same conference. So here's another example of a Saga in our system. The story goes like that. You place an order, but in ticketing industry, you have limited amount of time to buy the tickets because this might be a high-selling event, and there might be a lot of other people willing to buy the same seat as you. Maybe this is an Adele concert or something. And believe me, they are sold out for the rest of the year. And so we have in our system only 20 minutes to actually pay for those tickets. If you don't, the order expires. But it might happen that you were already on the payment gateway page and you already provided us with some details and decided to submit it. And the order expired a few minutes ago, but then you came back with the money and the payment was paid. And we reserved the amount on your credit card. And what do we do now? So what we do is that the the order and the delivery bounded context in our system will ignore the fact that the payment was actually successful, and the Saga will invoke the release payment command. So we authorized the amount on your credit card, but we didn't get it. And instead of like making the capture command and actually getting the money from your credit card, we will release the money. So it was there, it was authorized, we had a lock on certain amount of money on your credit card, and now we decide, okay, we are not gonna take this money. Let's release the money and give it back to the customer. And so that's how the story goes. The payment was paid, but the order was already expired a few minutes or a few seconds ago. There's like race condition between these two things, expiration and getting back from the payment gateway. So yeah, that's another Saga in our system. So these are the examples of Saga and how we reach them, but how do you actually implement one? So we started first with the synchronous handlers that are triggered by our event store. So the API is very similar to REST because we wanted to handle the asynchronous and synchronous events in the same way. So you have this perform method, and it's taking event, and usually in the perform method we initialize the handler with some kind of dependencies, and we call the method call. Okay, in this example, the handler does not have any dependencies, so it's a simple situation. But in case of more complex handlers, there are some dependencies that we pass, and this is nice because in tests you can just create a different instance of the handler with different dependencies passed with some stubs or mocks, and test it without using the perform method, but just by initializing the handler and using the call API and passing the event there. And when you use synchronous handler, you need to be really sure to catch the exception. Why is this important? Imagine that we have this register event service, which is creating the user and publishing an event. And we have all those wrapped in a transaction because we want the event to be only saved when the user was actually registered. Yes? That's what the transactions are for. And imagine that when the user registered by email when the user registered by email event is published, and the user registered handler in the search bounded context is triggered, imagine that something goes wrong with Elasticsearch. So for example, it's down and we can't save the user in Elasticsearch. So there is an exception. And if we don't catch and swallow the exception, it would bubble up and it would rise and it would roll back the transaction. So even though the user actually registered in our system, we would roll back the transaction because we can't connect to Elasticsearch. That doesn't make sense. Just because something wrong happened in one particular place in your code base, in one bounded context, doesn't mean that anything will go wrong in a different places. So you have like these multiple subsystems in your system. If something goes wrong here, notify the developers, but let other things in different part of the system carry on and move on. And this is quite easy with the handlers. Some point later, you might want to introduce asynchronous handlers because it actually can simplify quite a lot of things. So this is the core of the event dispatcher in our event store implementation. And so you have an event, and now we need to dispatch to all the handlers, to all the subscribers. And if the handler is having the queue instance variable defined, which is how you create queues and background jobs in REST, we detect that is asynchronous, and we serialize the event with YAML, and we just enqueue a job on the REST background queue. And if the handler is synchronous, we just immediately call it with the serialized event, and we want to trigger the handler immediately. So this is the simplified version, because actually it looks a bit more like that. So there's one thing that we want to remember, is that the events are often published inside a database transaction, and if you publish the event and have a background job that will take the event, and try to find, for example, something on database, it might not yet be there because the transaction from your application HTTP server might not yet be committed. So what we actually do is we use the after commit functionality from ActiveRecord, and we publish the asynchronous subscribers. We want them to process all the jobs, all the events, only after the transaction is already committed. And we use the same mechanism that ActiveRecord uses. Okay, you might be wondering, why are you serializing the events with YAML? It's such an odd choice. And there are two reasons for that. So if you don't have schema on your events with YAML, you can easily serialize more complicated types like date or time. So for example, in JSON, if you serialize and deserialize, you would get string instead of actually the time class. So it's easier for the events where you don't want to define schema, you just go on with whatever is inside the event data. And the other thing is that YAML can easily serialize value objects. So for example, seed in our system is the seed label. So like first row and second seed in that row, it's a label. And we have category. So the first seed might be VIP seeds. And it's a very simple value object with two attributes. And YAML can easily serialize and deserialize it without providing the schema for it. So if you have asynchronous handlers, then you don't need to swallow the exceptions because they are asynchronous and isolated. It's one background job. And so you can rewrite the exception, and in your RESCA panel, you will see that the exception is there, something went wrong. And when you fix the bug or fix the situation like networking problems, you can retry the handler later and fix something in this particular bounded context, this one small module in your application. So I told you that the events, that they can occur at different times, and sometimes they can occur at almost the same time. There's like race condition. But the Saga needs to process them one by one because the Saga is making decisions based on the event that it's currently processing and the state from previous events. So the Saga needs to process the events one by one. So we achieve that by using simple logs on database. So if the Saga state is already in the database, then the log find or create will use select for update statement in database, and the record will be logged. So we are sure that this one process will be updating the Saga state at this time only. And if there are two competing processes trying to instantiate the Saga state, then what saves us from the problem is that there is unique index on database on the order ID in the Sagas table. So only one of the processes will be able to create the record on database and save the state, and the other will get the ActiveRecord record not unique exception, and it will retry, and then it will find the record created by the previous process. So we initialize the state of the Saga when we are processing the first event, and then we need to process the event somehow. So usually in our case, this involves like calling some kind of method on the state, for example, fill out. And we save the information that something was added to basket, or that it was filled out or paid. And we use this kind of Boolean flags, but instead of Boolean, we just save times when these things happened. And in all those cases, we call the maybe send postal via API methods. So let's see it. What this method is trying to do is checking whether all the conditions required to invoke a command already occurred. So it's checking added to basket, paid add, filled out, and generated, and if it wasn't already processed one. And if all those things already occurred, so we are at the fourth event in our story, all those things happened, then we are using the uploader adapter to send the PDF to some service that is capable to sending the postal tickets to our customer. And here's one problem with that. So this method needs the uploader, needs this object and to call the command, which is transmit in our case, on. So we need the uploader. And where does it come from? Okay, we have it here, but where does it come from here? Well, someone had to pass out to us. So in our case, it was the handler that had to pass the uploader adapter. So the handler needs to know about this adapter, the state, the method which is triggering the command. So many methods needs to know about it. And that's not good. There must be a better way to do it. And we are not there yet in our code base, but I already know that there is a better way. It's called command bus. So command bus is this utility that will take a command and it will deliver it to whichever service is capable of processing that command in your system. And you already have one very similar thing like that in your Rails application. It's on different layer, it's on HTTP layer, and it's the router. The router in Rails application takes the URL and it decides which controller is capable of handling, and there is only one controller that can do the job. And command bus is doing the same thing for you, but instead of taking requests, it's taking command and it's delivering it to the services that are to the one service that is capable of handling this. So because of that, your code doesn't need to worry when this is going to happen and who's gonna handle this command. It just uses command bus, which is like the second bus in your system. We already have event store, which is one bus that we use to store event. And now we have the second bus, the command bus, that we can use to put their commands. So we have this message-driven architecture with command and events, and we have one bus for events and one bus for commands. So that's the way to go. Okay, that's it from me. Thank you very much. There is one more story that I wanted to tell you, is that in my entire life, I've made $15 from writing open source software. So a few years ago, I wrote this ActiveRecord library that was used to speed up the development in Rails development mode, so the Rails was faster. Later, it was incorporated to Rails, and I had this donate button on the GitHub page of ActiveRecord. Thousands, if not hundreds of thousands of people downloaded this game already, and only one person paid me $15 of donation, and I use it to buy flowers to my wife, and that's my entire revenue from open source. But for some reason, in last year, in our company in Arkansas, we made $50,000 on selling books for programmers. So there's something in programmers that they are much more willing to pay you if you have a book, if you share the knowledge, and people are willing to invest in their brains. So if you want to thank me, if you want to see what we have, you can check out our books for Ruby and React.js developers and buyers. But if you are not yet convinced, just follow me and my company on Twitter. Follow me on Snapchat. If you're not on Snapchat yet, you don't know what you're losing, because there are much more developers nowadays on Snapchat. And so you don't only need to use it to watch fashion people showing things, but you can actually use it to watch the developers talking about code and their daily lives. So that's it for me. Follow up, sign up for our newsletter and YouTube videos. And if you like our content, you can sometime later buy or not our books. Thank you. Pięć po? Okay. Okay, so we've got a lot of time for questions. If you have any, I will be willing to answer them. Yeah?
So it was 2 years ago when you published your first event.
Yes.
And how long ago was when you started handling them actually?
I think it was weeks. So first we started publishing them. Nothing went wrong. We didn't have deadlocks on the event store table, which I feared on. So you start publishing those events and you don't know what's gonna happen. It sounds so weird. Nothing wrong happened. So we started to adding our first handlers, and the first handlers were the synchronous. When you have legacy code base and you have these big services, it's quite easy to refactor so that the side effects are moved to the synchronous handlers, and it's quite safe refactorings, especially considering that other parts of your application might assume that the thing that happened there actually already happened. They can be asynchronous. But if you keep continuing refactoring more and more and more, then the new handlers that we are adding right now, they are all asynchronous, but we have still some kind of older handlers which are synchronous, well, because legacy. And it's still gonna take some time to refactor them to be asynchronous. Cool. Thanks, guys. You have now 20 minutes to find out the new talk and switch the rooms. Thank you very much.